Hello and good evening to everyone. Today's session is day number 18. So we are continuing with 7.3 on Introduction to Occupational Exposure Limits. Okay. So what are occupational exposure limits and what are the purpose of these exposure limits? Now, for noise, we discussed about the exposure limit, which is the general agreement is 85 decibels for an 8-hour time weighted average. So likewise, for many substances, there are occupational exposure limits defined. Okay. So the purpose of this is to ensure the worker exposure is not, above this limit. Okay. So if a worker exposure to a substance is above these defined exposure limit, then there is a strong likelihood that it could cause serious health effects. Okay. So these are used as part of monitoring to ensure worker exposure limits or to a particular substance or below these exposure limits as defined. So exposure limits, occupational exposure limits, in, there are various terms used like workplace exposure limits, okay, or threshold limit values. So the meaning is these limits of exposure that are set to protect the health of workers. They identify the maximum concentration of hazardous substances in air average over a specific time period. Now, what it means is these limits can only be applicable where the exposure is, through inhalation. Okay. Now, for example, if the exposure is to a dust or to a substance through inhalation, okay, then these exposure limits would be useful. If an exposure is through absorption through the skin or ingestion through the mouth or through injection through the skin, then these limits they don't add any value because it clearly tells they identify the maximum concentration of the hazardous substance in air averaged over a specified time period. Okay. There are short-term limits that apply to a 15-minute period control to control acute effects and long-term limits averaged over 8 hours to control chronic effects. The reason is at times a worker could be exposed to a high concentration of substance where it could lead to acute effect. So in those instances, the 15-minute short-term limit will be applicable, and where the exposure is to a low concentration of a substance, then long-term limits would be applicable, which would be averaged over an 8-hour period. Okay. Now, how to calculate these exposure, the time weighted average value is similar to how we did for the noise. Okay. So as a worker, they might be exposed to different levels of noise in an 8-hour period. So we have to collect the data of what are the, to the noise level they are exposed, for how long they're exposed in a working day, and then we find the average. Okay. So long-term and short-term exposure limits on concentrations of a hazardous substance in air. So long-term exposure limit usually averaged over 8 hours intended to help control chronic health effects. So yesterday we discussed about chronic or the long-term effect. Okay. So why the effect is long-term? Because we are exposed to the exposure is repeated and the exposure is to a low concentration levels. Whereas acute effects, the effect is immediate because the exposure is to high levels of a substance for a very short period of time. Hence, the effect is immediate. So for acute adverse health effects, short-term exposure limits are used. So here you could see how to calculate the time weighted averages. Okay. Now, before this, there is one a document which is EH40. So EH40 is environmental hygiene, and you could also refer to that over here. You see this 120. Okay, you can click this link. It takes you to that particular page, or you can also go to HSC, or even you could go to the Google and search for EH40. Okay, so I search here. Okay. So in this document, we would find a table. Okay. So table one. So the major chunk of the document is this table. This table is a list of approved workplace exposure limits. Okay. So this table contains the column one, the name of the substance, CAS, chemical abstract substance number, like a identifier for a substance. And then we have the workplace exposure limits, which have one is the long-term exposure limit, which is 8-hour time-weighted average reference period, and the other is short-term exposure limit. Okay, so for each of the substance, I mean, for substance where exposure limits are defined, will be is included in this table. So for instance, if I take the substance acetaldehyde, the ppm, okay, the parts per million, so 20 ppm is the long-term exposure limit. Okay, now we'll go back to this definition. Okay, so what is occupational exposure limit? They identify the maximum concentration. So for example, this 20 ppm. Okay, so 20 ppm is a maximum concentration of hazardous substance. So here the hazardous substance is the acetaldehyde averaged over a specific time period. So here this is for an 8-hour time weighted average. Okay, so now if you read the definition, you could see the understanding. So for acetaldehyde, 20 ppm is the maximum concentration to which a worker could be exposed for an 8-hour time weighted average, because that limit is defined over here. Okay, now how to, so this is the exposure limit for acetaldehyde, which is LTEL, long term exposure limit. Okay, now going back to the presentation, so how to calculate the TWA? Okay, so to calculate TWA, we need two data. One is what is the concentration of the substance, okay, in the work environment, and what is the exposure period. Okay, so similar to noise, what is the sound level to which a worker is exposed? Let's say 90 decibel. And what is the exposure period? Let's say 2 hours. So we collect the cumulative data for 8 hours, and we determine what is the TWA, time weighted average. So multiply each measured concentration C by its corresponding exposure time T. And then you add all the values of C and T together and divide by 8. Okay. Now here is an example. So consider a worker working an 8-hour shift. This worker is also using trichloroethylene as a degreasing agent during their working day. So the exposure here is to the substance which is trichloroethylene, which is used as a degreasing agent. The worker's personal exposure to this TCE vapor has been measured. So using a monitoring device and equipment, they measured during the day. and the table shows their exposure for different time intervals. Okay, so when the worker is doing a task one, okay, the exposure to TCE vapor is calculated as 80 ppm and the exposure time. So for 3 hours, he is doing task 1. So during this task 1, the concentration in ppm is 80. So similarly, when doing a task 2, a different task, this time maybe he is cleaning uh, the equipment or something, okay, or maybe he is just handling or transferring. So during task 2, his exposure time is to 1.5 hours. So 1.5 hours is doing task 2. During task 2, the concentration measure is 200 ppm. So all these are to the same substance TCE. Similarly, task 3, exposure time is 2 hours and the measured concentration in parts per million is 30. So break is for 1.5 hours. During break, there is no exposure. So we multiply the C and T. Okay. So multiply each measured concentration by its corresponding exposure time. Okay. So we find what is C times T. So 3 times 80, 240, 1.5 times 200, 300, 2 times 30, 60. Now we have to add all the values. Okay. So 300 plus 240, 540 plus 60, 600. So 600, okay, and you divide by 8 hours, which is the time weighted average. So 600 you divide by 8. So which gives a value of 75. Okay. So 75 is the 8-hour TWA for this TCE vapor. Now you are going to compare this 75 with the occupational exposure limit of TCE. Okay. So for example, so from the data, we calculated the time weighted, the 8-hour TWA for TCL is 75 ppm. Okay. Let's say, let us consider, okay, for example, okay, the occupational exposure limit for TCL, okay, from the regulatory, okay, is, let's say it is 65 ppm. So now your exposure is 75, the exposure limit is 65. So the exposure is uncontrolled, okay, because of 75 greater than the exposure limit of 65. Okay. So if where it is uncontrolled, now you have to reduce this 75 to below 65. Okay. So how you can reduce it? One, you reduce the exposure time. So see, this is the activity. Task 2 is where the concentration level is very high. So you reduce this exposure time from 1.5 to, let's say, 1 hour. It will significantly reduce to 200. Okay. Or using engineering controls, you reduce this 300, let's say, to 150. Okay. So through engineering controls, where you could aim reducing the concentration level, or through admin controls, reduce the exposure time. So therefore, the overall value would also reduce. Okay. So is this part clear? But again, in your risk assessment, you're not going to do any calculations. This is only for understanding how to calculate TWA and how they can be useful to measure worker exposure is within the limit or not. Okay. Now 7.4 is control measures. Now if you have a convenient free time, just go through this document. You don't have to go through all. Okay. So there are some examples would be given here for more clear understanding. See from page number 32 of this document. So there are some examples very similar to what we have discussed, just for your reference. 7.4 control measures. Okay. So the need to prevent exposure, or where this is not reasonably practicable, we control it. Okay. So going by the hierarchy of risk control, elimination, okay, which is the most effective control, because you eliminate a hazard, the risk also will be, will disappear. So where eliminating the hazard is not, reasonably practicable, then we must implement controls to control the hazard. Okay. Eliminate the original chemical hazard or substitute it for something non-hazardous or much less hazardous. Okay. Now substitute. Yesterday we discussed about the different, how these substances, they are categorized based on the severity. Okay. So severity to health effect categorization we discussed yesterday. So for example, toxic, okay, corrosive, and then irritant, okay, carcinogen, mutagen, okay. So these are all the the how the substance are categorized. Now, when we talk about a substance, we can consider substituting a toxic to a less toxic substance, okay, or substituting a corrosive, okay, to irritant. Okay? Because corrosive, the severity is very high compared to irritant. So we are not eliminating, we are replacing one with another which is non-hazardous or less hazardous. So though irritant may cause inflammations to the skin, but the severity level is less compared to corrosive, which may cause burns to the skin. And then prevent exposure to the hazard. Okay, through engineering controls, how you could prevent exposure, and these may not be possible or can inadvertently, without intention, introduce new risk by eliminating another risk. So your intent might be to eliminate one risk, but in that process you may introduce another risk. Okay. So yesterday when we were discussing about day before yesterday, the load handling equipment. Okay. You're introducing load handling equipment, for example, a forklift truck. Okay. So FLT is introduced to eliminate or to minimize manual handling risk, right? But the forklift truck, okay, so however, the FLT will introduce new risk, okay, such as FLT overturn, okay, or collusion, or fire. Okay, so these are the new risk that would be introduced by by introducing the FLT. So likewise, we'll often need to introduce one or more control measures to reduce the overall risk to an acceptable level. Okay. So we will discuss before this. Now, health surveillance. So where exposure to a hazard may cause, ill health effects. Okay. So where it is causing, more of a health hazard than safety hazard, then the importance of health surveillance is very much prominent. Okay. Health surveillance is to prevent occupational injuries and ill health through consultation with workers or their representatives. Now, for noise, one of the health surveillance we do is a audiometry test. Okay. So likewise, for vibrations, there are certain tests that are conducted, uh, like nerve test, and then where the exposure to a substance may target the lungs organ, then respiratory, lung function test will be done. Or where an exposure can cause irritant to a skin, then skin test will be conducted. So health surveillance is a form of medical examination or ongoing medical examination to identify the signs and symptoms of these uncontrolled exposure in the workplace. So where a symptom is identified, then immediate corrective actions or controls would be taken to prevent the symptoms from turning into a long-term health effects. So the conditions under which a health surveillance is carried out will be in accordance with the requirements of individual countries. So there are a strong, strict regulatory requirements. So that needs to be, to be complied, because with health surveillance, there are sensitive data that are collected. So it is very important to check the local law. So common measures used to control exposure. Use of a totally enclosed process and handling system. Okay. So where reasonably practicable, the exposure must be prevented. Okay. So by completely, using an enclosed process and handling system. Now, for example, if you look into the paint spray booth in a workshop, okay. So this is an example of an enclosed, you know, uh, so totally enclosed process where the paint spraying activity is done in an enclosed area. So this will prevent the escape of these airborne particles from the paint spraying activity to the other parts of the work area. Okay. So where the work process or activity may create, these a form of hazardous substance, like in the form of mist or vapor or gas, then it is very much recommended that it should be done in an enclosed space. Okay. Or segregation of hazardous process from the workers. Okay. So again, these processes are completely done in an isolated area. So where the entire process area is totally isolated from other parts of the work area. Plant and process that minimize generation or suppress or contain hazardous dust, fumes, or gases, and that limit the area of contamination in the event of spills or leaks. Okay, so where practically, reasonably practicable, so design process in such way that it will reduce the emission of these, hazardous substances in the air. Okay. And now, or we can completely eliminate such process. For example, instead of welding, buying prefabricated components. Use of partial enclosure with local exhaust ventilation. Okay. What is a local exhaust ventilation and what is its purpose? Okay. So from the image you could see these local exhaust ventilation, what it does is the fumes, for example, the fumes generated from this process, the contaminant is directly captured in this intake hood, and then it goes through the duct, and then there would be an air filter. The filter will remove the contaminant from the air, and then the clean air will be discharged through the outlet. So it will remove the contaminant from the work environment. It filters the contaminant from the air, and then a clean air would be discharged. So this local exhaust ventilation will come in different sizes and different shapes. Okay, so it could be very large enough. So for example, like here in this, okay, or it can also be attached to the tools. Okay. I will just play this video. Okay, I haven't played. I'll play this video. If you have any trouble in the video playback or in the audio, just put a message, okay? And I'll just reshare. I don't know whether it is going to use the system sound. It's just a 2-minute clip. Okay, if I'm going to share sound. Okay. All right, I'll play here.
Lots of different jobs across different industries involve work processes that create dust and fumes. If these are not controlled properly, people can breathe them in and develop diseases such as asthma, lung scarring and cancer.
Is it audible?
Yes, we can hear.
Okay, thank you.
Of different jobs across different industries involve work processes that create dust and fumes. If these are not controlled properly, people can breathe them in and develop diseases such as asthma, lung scarring and cancer. Every year, thousands of people in Great Britain die as a result of breathing in harmful dusts and fumes at work. A common way businesses can control dust and fumes is by using local exhaust ventilation systems, or LEV, also called extraction or fume control. LEV systems can be very effective at controlling dust and fumes, but it is vital that people understand how LEV works, so that they buy the right LEV and use it properly. LEV systems all work in the same way. In this example, 2 hoods are used to enclose the saw blade, one above the table and one below. The LEV airflow into these hoods carries the wood dust away. The contaminated extracted air is transported through the ductwork to the filter and fan unit. The filter removes the dust from the air. The fan creates the airflow. It's the motor that moves air through the system. An LEV system will often provide extraction at more than one machine. Getting the right type of LEV hood is the most critical step. If the hood design is right for the process, then it is possible to control the dust and fume. Soldering work produces fume which can cause asthma. Here, the worker is protected by the LEV hood and system. But how does it work? The hot fume cloud rises, but is prevented from reaching the woman's breathing zone by the enclosing hood. The LEV airflow draws the fume-filled air away. The enclosure and the airflow act together to protect the worker's health. Enclosures can be very effective, but in practice, LEV hoods come in all shapes and sizes, from ones which are large enough to stand in, to others that are tiny and built into tools. LEV hood design is critical to controlling dust and fumes. For almost any dusty or fumy process, there is an LEV hood and system design that will provide effective control. Make sure your LEV is the right sort and is properly applied. Well-designed and applied LEV systems can really protect your workers' health. Professional advice is widely available. You can get competent help from your trade association or a professional advisor. Printed guidance on how to choose and use LEV is
Yes, so LEV, as we could see from the description, so the purpose of these LEV, it will remove the contaminant from the point of source. Okay. So from the source, it extracts the contaminant, and then it moves to the main duct. And then there we have air cleaner, which will filter out the contaminant from the air. And then you have a fan to, the power to move the air throughout the system. And finally, where you have an exhaust or a stack or an outlet through which a clean air would be discharged. So for these LEV to be effective, okay, it is important where we are positioning the inlet hood. Okay, so the inlet hood or the intake hood, it must be positioned very close to the area, or to the source of generation. Okay, so for example, from the welding, where fumes are generated, the hood should be placed very close to that area where the fumes are generated, so that those fumes would be directly captured into the hood. See? And then the shape of the hood is also important, so that these contaminant, they do not enter into the breathing zone of the worker. So size of the hood, shape of the hood, the positioning of the hood are all critical for the effectiveness of LEV. Okay. And then for the duct, okay, so duct also, a proper maintenance is required. Otherwise, these contaminant, they can get build up inside of the duct. Okay, and then over a period of time, they will not, enter through the air cleaning unit, and the dilution will not happen. So it is important to ensure these ducting are properly maintained, and see what is the transfer velocity of air inside of the duct, and the filter to be replaced at regular intervals, so not to get saturated, the speed of the fan and the motor system to ensure these air, there's sufficient air inside the system for the movement, and the exhaust duct. Okay. So there is a comprehensive guide for the thorough maintenance and inspections of the LEV systems. Okay. So when you're writing the control measures, if LEV is one of the control identified, then you're just going to say that whether the LEV system is in place and what is the purpose of the LEV. Okay. So for example, I would say, so you don't have to explain the components of LEV. Okay. So, so as an existing control, I may write the LEVs are installed at the welding process area to extract the contaminant and filter out from the air to protect the worker. So you're just going to say whether LEV is installed or not, and what is the purpose of LEV. Okay, so we are not going to explain the components, each components, or we are not going to describe this picture. But again, an understanding is very important. So we put that control in a very proper, clarified words. So next is the PPE. Okay, so there are different types of PP. So PP to protect the skin, PP is to protect the whole body. Okay, PP to protect the eyes, and PP to protect the respiratory system. So we'll go one by one. Skin protection gloves. Okay, so to ensure the PP provides the adequate level of protection for the user, it is important to choose these gloves which are, appropriate for the hazard exposed. Okay. So the gloves should be of correct size and length, so it covers, your entire the hand until the forearms, and the durability of the gloves, comfort, particularly if you have to do some skilled job using your hands, the length of time they would be used, and whether they can cause any allergic reactions. Sometimes these are latex and all, they can cause allergic reactions. And training for safe removal. So there is a proper procedure when you are removing the gloves and how you dispose of them at the gloves. Okay, so we need to identify. So the safety data sheet will specify what type of gloves, or a proper risk assessment will help you identify what gloves should be used so they provide adequate protection. And then whole body protection. So where to provide protections from the chemicals or chemical resistant suit. So paper disposable overalls, liquid resistant overall to protect against aggressive chemical, example corrosive liquid. So where this liquid could be spilled or splashed. Okay. And then water cooled overall for hot atmosphere while using aggressive chemicals. And then eye protection, different types. One is safety spectacles, safety goggles, and face visor. So face visor, it provides a protection for the face. So it completely covers the face as well as the eyes. Goggles, minimum protection for eyes against hazardous substances. And with the goggle, it will also completely encase your eye. So even the gap between, your eyes and the frame will also be sealed. So with the goggles, okay. And then safety spectacle, unlikely to provide sufficient protection against hazardous substances. But again, very much they can be used where the exposure is to a very, a low concentrations of the substances, or even these can also be used for, any flying particles. So the correct eye protection must be used. And then respiratory system protection. There are in short referred as RPE, which is respiratory protective equipment. There are two types of RPE. One is breathing apparatus, the second respirator. Okay. Now, breathing apparatus is very much appropriate where the exposure is to a toxic substance. Okay, because for a breathing apparatus the oxygen is from an independent source, whereas for a respirator you're inhaling the air from your immediate work environment, but there is a filtering element. Okay, the filter in the respirator, it will filter out the contaminant before you inhale the air into your body system. Okay. So with RPE, we'll go a little detail about RPE. So we'll just focus on the RPE types. Okay, here from the pictures, and yeah, RPE types, the breathing apparatus and the respirators. Okay. Work activities may result in harmful substances contaminating the air in the form of dust, mist, vapor, gas, or fume. Okay, so the work activities that we do may create, these harmful substances contaminating the air. So, for example, when you're cutting a material such as stone or wood, okay, in a wood workshop, okay, or in a construction, you're cutting a stone for the pavement, or using a product containing volatile solvents, so they vaporize, so vapor is formed, or if you're handling a dusty powder or welding a stainless steel. So all these activities will contaminate the air in the form of the mist, dust, vapor, or fume. Okay. So workers may also need to work in areas where oxygen levels are or may become low. For example, in a confined space. Okay, so working inside a storage tank for cleaning or maintenance. Okay, or working in a pit. Okay, which is more than 4 feet. So these are examples of confined space where the oxygen level would be very low. So in those circumstances, also uh, RPE will be a requirement. Okay. So two types of RP. One is respirator. So a respirator will have a filtering device. Okay. So what happens is the filter will remove the contaminant from the air that we breathe in. Okay. But in a breathing apparatus, there is no filter. Okay, because the supply of breathing quality air, we are not breathing air from the immediate working environment, but rather the air is from an independent source. For example, a air cylinder or a air compressor. Okay, so for example, this the air is from the air cylinder, so there is no requirement of the filter. Okay, now as we go through the appendix, okay. RPE types. We'll just look into a few pictures of different RPEs. Disposable half mask respirator. Okay. Here, as you see from the image, so these are disposable. So you dispose of after the shift and they are not reusable. And it is a half mask, so it doesn't provide a full protection for the face. Okay. So where a certain substance may also cause irritant to the eyes, then half mask respirator will not be ideal. Okay. And then reusable. So the earlier one is the disposable, and this is a reusable half mask respirator with a particle filter. So it means you can use this where the contaminant is a particle, okay, not gas or vapor. If it is a gas or a vapor, then we use reusable half mask respirator with a gas vapor filter. Okay. So this is for gas vapor and this is for a particle like dust, microorganisms, okay, fumes, uh, fibers. For these, particle filter would be the appropriate. And then full face mask respirator with a particle filter. So here the protection is for the full face. Okay, so where the substance may also be an eye irritant, then a full face mask respirator is used. And the full face mask respirator for a gas vapor filter. Okay. And then as you scroll down, the breathing apparatus. Okay. So the compressed air cylinder is harnessed to the worker, and then you have a full face mask, a demand valve, a pressure gauge, and a medium pressure tube. Okay, so this breathing apparatus appropriate where the exposure of the substance is a toxic or a very toxic, or where there is an oxygen deficiency environment. Okay. Now, just one more thing I'll just discuss quickly. So there are different types of filters. Particle filter, as we have seen in the images, particle and gas vapor filter. So particle filters are used where the contaminant is a particle. Okay. So for example, dust, mist, fume, smoke, microorganisms. Okay. So if the contaminant is other than this particle, then you use a gas vapor filters. So these are filters, particle filters. They are classified according to their efficiency. Okay. Now, so P1, P2, P3. So low efficiency particle filter P1, P2 means medium efficiency particle filter, and P3 is high efficiency, where up to like 99.99 percentage of the particles would be filtered. So based on the efficiency, they are classified. And you can see here it says P3R. Okay, so P3 means high efficiency particle filter, and R means it is reusable. Okay, so these alphanumeric will help you to determine the classification of the particular filter. Okay. So, anyways, again, you just go through this document if you have time. But again, a very useful reference document to learn more about the RPE, which is respiratory protective equipment. Okay. And then we have other control measures for biological hazards. Okay. For biological hazards like bacteria or these virus and fungi. Okay. Disinfection. So use of a disinfectant to thoroughly clean the work area or the environment, which may be contaminated with this biological agent. And then engineering control measures. Okay. So, for example, where in the laboratory they are working with these, biological agent, they use something called like a glove box. Okay. Uh, Okay, you'll just insert your hand into these gloves, and then you work with that biological agent. Okay, so this is again a form of engineering control which prevents exposure to the biological agent. Okay. So a glove box is a sealed, controlled atmosphere enclosure that allows scientists to safely manipulate sensitive materials. Okay, so so you could see from the design of the glove box that you can work with these sensitive materials without being exposed. And then vermin control, pest control, because certain these biological agents, they are carried by the animals and insects. For example, rat. Okay, so rat, it is one of the carrier of a bacterial disease. So vermin control to eradicate these insects and other pests. And then water treatment. Okay, so again, certain bacteria, they are very much, they thrive in these contaminated water. So it is important to have a water treatment, like any water storage that you have. Okay, a storage tank or the condensers or the cooling towers. So water treatment. And then taking a great care about a personal hygiene. So washing hands before you step into the eating area, or do not eat or drink in the contaminated work areas. Okay. Or like in a hospital or sectors where you're dealing, working with patients, So a high amount of personal hygiene is required. Ensure proper disposable measures. So whether you're disposing your PPEs, okay, or the needle sticks, so they must be disposed of in an appropriate, a waste bin, which is for like even the medical waste and all the medical waste, like these syringes or you know uh, the plasters or anything that is used which may contain the blood or any body fluids of the patients. Okay, and then different types of PP and RP that will be required, from skin protection to the whole body protection. And then use of vaccination. So vaccination is a form of preventive control. So if exposure to a biological agent, okay, could result in a serious health effect, then vaccination would be taken as a proactive measures. So, like we do these vaccinations, right, for any type of viral infected diseases. So, use of vaccination or immunization for known effects. So next is specific agents. Okay. Now for specific under specific agents, we would be covering a certain specific agents like asbestos, carbon monoxide, blood-borne virus, wood dust, silica dust. So for each of the specific agent, we will discuss, what is the health effect, like the target organ or the target system, occupations more at risk from these specific agents, and the control measures. So control measure is very much what we have discussed here. Okay. So to just the overview of the controls, elimination, and then the substitution. So where we substitute a hazardous substance with non-hazardous or less hazardous, and then the engineering controls. Okay. So for example, the local exhaust ventilation, the glove box, okay, or a total enclosure. And then you have these PPEs. Okay, so PPEs, or I would say RPE, and then the other PPEs. Okay, and then health surveillance, and then biological. Okay. And we also need to provide them the training, awareness, and then the monitoring, especially the occupational exposure limits. And yeah, that sums up. Okay. And for more awareness, we can also talk about posters, comma, signs. Okay. So if there are any specific controls, if when discussing specific agents, we'll just include here. Okay. So these are the range of controls for hazardous substances, which you would be including in your column 3 existing and column 4 further actions combined. Okay. All right. So we will continue the specific agent after the break. Okay. So we will take a 15-minute break and then we'll start with and complete 7.5. Thank you. Welcome back after the break. 7.5 specific agents. So, under specific agent, number one is asbestos. Okay. So, what are asbestos and what are the health risks and the control measures? Okay. So, first, to know more about asbestos, so we can also go over here. All right. So, you could see here. So, there are many different forms of asbestos. Okay. It is a naturally occurring fibrous silicate minerals once prized for its strength, heat resistant, and insulating properties. Okay. So, asbestos has been widely used for these properties. They are good resistant to heat, okay, and also for their strength and insulating properties. Okay, and it is classified as a known carcinogen, so which means it is a cancer causing substance. Okay, so now there are countries, a few countries that they have strictly uh, eliminated asbestos, and other countries there are strong regulatory for controlling asbestos. So the primary reason is due to the health risk that it poses. Okay, so number one is the lung cancer, next asbestosis and mesothelioma. Okay, so lung cancer, so these asbestos fibers, they are cancer causing agent. So when they are in in a respirable form, okay, like 10 microns and less than 10 microns, they can travel deep into the lungs. Okay, and if you look into these fibers in the microscopic, they are very hard and sharp. Okay, so once they go and deposit in the lungs, they cause uh, this abnormal growth of these tissues in the lungs causing cancer. The same fibers in the lungs, it will cause the puncture of the alveoli of the lungs. Okay, so it will start to uh, form more scar tissues in the lungs. Okay, so it causes scarring of the lungs, and this can cause cancer. So this scarring of the lungs, the name of the disease is asbestosis. And then mesothelioma, where the asbestos fibers, they lodge in the lining of the pleura of the lungs, and this will cause cancer. Okay, so the symptoms here is shortness of breath, persistent dry cough, loss of appetite. But remember, all these are all chronic health effects. Okay, so it could happen from repeated exposure to a low levels of asbestos fibers, or even one-off exposure to a very high levels of these fibers. So these asbestosis and all would take like 15 to 20 years following exposure. Okay, so these are all chronic health effects. So in a building, there are many places where there are asbestos containing materials. Okay, for example, asbestos cement roof, sprayed coatings on ceilings, asbestos cement gutter pipes and down pipes. Okay, asbestos insulating board partition walls, lagging insulations on boilers and pipes because they are good resistant to heat, asbestos insulating board ceiling tiles. So you could see this asbestos has been used extensively. Okay, so after 2006 or so, in some countries they are completely banned. but in other countries they are subject to very strict regulatory requirement. Okay. Now, for these asbestos containing material, when they are in solid form, they do not cause any risk. Okay, when they are in solid form. For example, if this wall is an asbestos containing material, now when it is in solid form, it doesn't cause any health risk because there is no route of entry for this asbestos containing material to enter my body. But if there is a, any activity that is going to disturb this asbestos containing material, for example, like demolition or renovation or some maintenance, or if I'm going to do some drilling activities, so these asbestos containing material, now they become airborne. Okay, so the fibers and dust, so that airborne could be inhaled. So where work involves disturbing asbestos containing materials, then there are strong, very strict regulatory requirements. So in terms of control measures, separate, automate, or enclose the process. Okay, so the complete process area where like these refurbishment or maintenance, that area should be completely enclosed. So that these fibers, they do not escape the enclosed area. Okay. Reduce surfaces where asbestos dust and waste may accumulate. Facilitate cleaning of floors, walls, ceilings, and machinery. Facilitate collection of asbestos dust that may escape in the event of an incident. Okay. Now these asbestos dust, they should be asbestos waste. They should be treated as hazardous waste. Okay, so they should not be treated as general waste. So hazardous waste, they must be double bagged and handed over to the licensed contractor for disposal. Okay, so use of local exhaust ventilation, and then general dilution ventilation where they are in very low amounts. And then in terms of work practices, requirements to use maintain process, okay, tools and ventilation systems in accordance to the instructions provided, regular cleaning of machineries and work areas, proper use of appropriate PP. So a full body suit would be more appropriate when working with these asbestos containing materials. Ensuring negative pressure in the enclosed area so that these fibers, they do not escape into the the enclosed areas. Okay, and with a very high particulate efficiency filtering, it should be used. And good hygiene facilities should be followed because these are hazardous substance. So washing hands thoroughly on after working with them, and then do not eat or drink in those contaminated areas. Safe disposable of the PPEs. Okay, use of sheeting to cover the work area to segregate that area from other parts, and providing suitable monitoring. So it is also important to continuously monitor what are the dust levels in the environment, and enforcing strict supervision. Okay, so in your hazard category, okay, for example, in your hazard category, like I said, you could discuss any of the specific agent, or you could, in general, you could also discuss which is not under any of the specific agent. So they all come under one specific, sorry, one hazard category, which is hazardous substance. Okay. So for this hazardous substance, the source of hazardous substance can be anything. It could be an activity, like for example, we discussed here in this RPE. Okay. So for a hazard description, like here, cutting a material using a stone or wood, or handling a dusty powder, or welding stainless steel. So these would be your hazard description. Okay, you're describing what is the source of hazard. Okay, and then you would write the health risk. For example, if your hazard description is worker involved in the demolition, where it could involve disturbing asbestos containing material. So in the second column, you're going to talk about the health risk. So these specific health risks like asbestosis, lung cancer, mesothelioma, and also including what are the symptoms. Okay. So these informations you can also get to, gather from the internet and other guidance documents. And then in your column 3 and column 4, you're going to include a combination of these engineering controls, work practices, and administrative measures. Okay. So administrative measures, employers should establish and implement a general control program to reduce exposure to worker to asbestos. So reducing the exposure time, duration. Okay. The control program should include, okay, a description of the control measures. So where you're creating a high level of awareness to the people on what substance they are exposed and how it could cause a serious health effects, and how they should implement the controls to protect themselves. Okay. So any relevant technical information related to the efficiency of the control measure, like safety data sheets, air monitoring data, exposure limits, and then schedule for implementation of the control program. So if any doubt remains, seek specialist advice. So as we discussed in 7.4, the control measures. Okay. So you can talk about engineering controls for asbestos. You could specify the RPEs. Okay. And then other PPEs, the importance of health surveillance, because exposure to asbestos is strongly linked to lung cancers and other chronic health effects such as asbestosis disease. So health surveillance is an important control. And then you talk about training, monitoring, and other administrative measures. Okay. So next specific agent is blood-borne virus. Okay. So occupational at risk is from the hospital sectors, or any profession where they work very closely with other peoples. Okay, like firefighters when they are rescuing the people, or police. Okay. So these are some of the occupations at risk from exposure to blood-borne virus. So here the virus where it is transmitted through through infected person blood or their body fluids. Okay. So either the virus could be transmitted from one person to another person through their infected person blood, or the body fluids, like any fluids that are secreted or excreted from the human body. Okay. So BBVs are carried in the blood, and they can generally be spread from one person to another through contact. Routes of transmission are inhaling the breath of or having contact with another person who is already infected with the virus, exposure to splashes of the virus containing material like splashes of the blood or other body fluids, okay, which may contain this virus, injection of the virus through a broken skin. So again, if there are any damaged skin, it is important to cover the skin or with proper dressing, because damaged skin can also find an easy route of entry into your body. Or injection like forceful penetration through needle sticks or other sharp objects. So control measures carry out work in such a way as to prevent cuts or puncture wounds. So use of a safe procedure when working with these, any tools or equipment that could be a carrier of the virus. Where sharps are used, ensure there are adequate number of sharp bags or boxes available and they are properly used. Cover all cuts with waterproof dressings. Personal hygiene, prohibit eating, drinking, smoking while working in areas where bloodborne viruses are present, PPE's requirement, and then immunization where possible. So here we will include this. Yeah. And then the next specific agent. So for control measures, you just go back to the 7.4. Carbon monoxide, next specific agent where it is a colorless, odorless gas. Okay. Now, carbon monoxide is one of the component where the combustion process is incomplete. Okay. And the major source of emission of carbon monoxides are the vehicles and the generators in the confined spaces, the boilers or the heating appliances. So these are some significant source of emission of carbon monoxide. Okay. So signs of carbon monoxide poisoning. So it depends on what is the concentration level of the carbon monoxide that you inhale. At a very low concentration level, okay, it may cause a headache or nausea, dizziness, or if you're inhaling a very high concentration level, then it could cause breathlessness, collapse, and loss of consciousness. So these are the signs of carbon monoxide poisoning. And the controls ensure gas. So those who are working with these heating systems, working in boilers or these workshops where the emissions from the vehicles, okay, so these are some occupations at risk from carbon monoxide exposure. So ensure these gas boilers are regularly serviced, inspected annually by a competent person, and then install carbon monoxide alarms which will alert if it reaches a certain levels of concentration, and place an LEV system, local exhaust ventilation system, on the exhaust of the vehicles when it is necessary for engines to be running during maintenance or repair in the workshops. And then adequate dilution ventilation, so the natural vent or the powered fans. Okay, so these will dilute, that means it will reduce the concentration of these substances. So by inducing more air into the work area, more clean air into the work area, it will reduce the concentration of this contaminant in the work environment. So that is dilution ventilation, the use of powered fans, the normal ventilations, okay, vent systems. And then the importance of awareness through informations and training about the risk of exposure to carbon monoxide or where they experience these symptoms, and how well the reporting systems that you have in place. Okay. So please read through the informations from your study book. And then cement, the next specific agent. So cement, the occupations at risk from the constructions where in the bricklaying or where they are preparing this mortar. So those are occupations at risk from exposure to cement dust. Okay, health risk, when they are in a powdered form, it can cause irritation to the eyes. If the cement is blown to the eyes, eye irritant, or contact with these powdered cement can cause irritations. Okay, and then severe respiratory. So if inhale, so you could clearly see what are the root of the contact. So inhalation uh, causing irritation to the respiratory, and then soreness to the nose and mouth, skin irritant, and eye irritant. When they are in wet form, they are corrosive. Okay, so corrosive due to its strong alkalinity, and skin burns very likely. And wet cement in the eye would cause significant eye damage. Okay. So control measures: use ready mix to eliminate exposure risk. If ready mix cement is not available, mix in a well ventilated area or work upwind if mixing outside with no cover. Remove jewelry because there could be uh, ca- a carrier of it. So cross contaminations can happen. Carry out regular skin inspections. Wear suitable body covering PPE, waterproof shoes, alkali resistant gloves, and RPE, the respirators. with the filtering device when handling powdered dry cement to protect your respiratory system. And then the importance of informations and training. Okay, so awareness and I'll put the word informations, instructions. Okay, and then here supervision and some specific agent depending on that maintenance of the equipment. Okay. All right. Next specific agent is a bacteria which is called as a Legionella. Okay, so it's a Legionella bacteria. Okay. Now this bacteria, it is a water-loving soil bacteria because this bacteria you could find in the water sources, whether it is an artificial or a natural water sources. The bacteria will be, they could thrive in those water conditions. Now this Legionella bacteria, what are the ambient conditions for these bacterial growth and the health risk? So here the target organ is again the lungs, and what are the control measures? Okay. So it is a collective term for diseases caused by Legionella bacteria. Okay. And people at risk of this is the risk increases with age, and some people are at higher risk, including people over 45 years of age, smokers and heavy drinkers, because this smoking will affect your body respiratory defense. Yesterday when we are discussing, your body has an inbuilt defense system to protect from these, dust and other contaminant when you're inhaling. For example, the the generation of this mucus, okay, and so what happens is these smoking or heavy drinking, it will affect your body self defense, and thereby you become more prone to those risks. Okay. And people suffering from chronic respiratory or kidney disease, diabetes, lung, heart disease, and anyone with an impaired immune system. Okay, so where your immunity is very low, so these are white cells in your body. They fight against these agents. So with impaired immune system, so these bacteria would find a very easy route of entry and to attack your target organ. Okay, so where it comes from? Okay, so these bacteria are widespread in natural water systems such as rivers and ponds. However, the conditions are rarely right for people to catch the disease. And also with the artificial systems like in the cooling towers, evaporative condensers, hot and cold water systems, spa pools. So where there is water sources, then uh, the presence of this bacteria could be there. And how people get it. Okay, so these bacteria, people they contract this disease by inhaling small droplets of water suspended in the air containing the bacteria. Now, if you go back to the history of this, what is the first outbreak of this, the bacteria, or how this bacteria it got its name lesion. Okay, now if you so before that, what is the meaning of legion? Okay, so legion refers to a group of people or things, especially related to these militaries and all. So they are referred to as legion. Okay, and if you look into the how this bacteria got its name. So it got its name after a 1976 outbreak. Okay, so what is this 1976 outbreak? So at that time it was a mystery disease. So in 1976, Legionnaires disease outbreak occurring in the late summer in Philadelphia, Pennsylvania. So what happened in a nutshell is there was a meeting, the American Legion. So those people, they gathered around 2,000 people, mostly men. They attended a convention in a hotel in Philadelphia. Okay. And I think it went for 3 days. Okay. So 3 days after the convention ended, those who attended, they started showing these symptoms like headache, fever, muscle pain, shortness of breath, and some people they even died. So the investigation, led to this particular hotel where they all attended this convention. Right. So during the investigation, they found that there was a unknown bacteria that was breeding in the cooling tower of this hotel. So through the air conditioning system, these from the cooling tower, the droplets of the water that people who are inside when they are inhaling, the fine droplets from this air conditioning system, which is already contained with that bacteria, they were inhaling. So that's how they contracted this bacteria. Okay. And if you go down, okay. So, anyways, you can go through that. So, talking about this, uh, so two diseases can occur due to exposure: Pontiac fever and Legionnaires disease. So, the target organ is the lungs. So how it can happen is by inhaling the droplets of water which contains this bacteria. So for this bacteria to grow, these conditions are very ideal. So if there are any stagnant water, okay, the bacterial growth will increase. Where there are dead ends in a water system. Okay, for example, again, the water in your your entire water system where some of the water are never been used. Okay, and then sludge deposits in a water system. These algae. Okay, or where water has not been treated with agents to kill bacteria, like no chlorination, no biocides, no proper cleaning of the water storage systems, okay, or parts of water system that haven't been used in for some time, okay, or any water between the temperature 20 and 45 degrees Celsius, it will promote the bacterial growth. So if the water temperature is above 45 or 60 degrees Celsius, these bacteria will not thrive. Okay. So these are the ambient conditions that encourage the growth of the bacteria. So in terms of the control measures, design water systems that have no dead ends. So there is no uh, place in the system where the water will never be used and stays for a very long period within the system. And then keep cold water below 20 degrees Celsius and hot water above 50 degrees Celsius. So if you are using any hot water storage system or cold water system, then these are the temperatures to be maintained. Test water regularly for Legionella bacteria and then treat water with chemicals. So here you could see the control is very much on water treatment because these are water loving bacteria. So treat water with chemicals to kill bacteria Maintain water systems regularly. So there should not be any buildup of scale, rust, or age. All these provide nutrients for the bacteria. Okay, any rust in your pipelines or in your shower heads or buildup of scale, a chalky deposit, especially in the hot waters, pipes or in the taps or in the or in the shower heads. What is the right they have used here? Buildup of scale. So you could see here. So these are all provide nutrients for these bacteria. Okay, and then rust and sludge. Flush water systems regularly to avoid buildup of stagnant water. Okay. For instance, let's say you're out of your home for let's say 10 days. So after 10 days, you come to your home, and it is very much recommended that you run the water for like 20-30 seconds, because the water systems the water in the water system has been stagnated within the system. So you run the water for like few seconds, like 20-30 seconds, and then you start using it. So flush water systems regularly. So even if certain areas in the workplaces where the water systems will never be used, so flush the system regularly to avoid buildup of stagnant water. Okay. And then the next bacteria is Leptospira bacteria. Okay. So these can cause a bacterial infection called leptospirosis. Okay. So how this bacteria, pass from animals to humans. Okay. So especially the main carrier of this bacteria is the rat and the cattle. Okay. So this bacteria, it will target the kidney of the rat. When the rat urinates, the bacteria also pass along the urine of the rat, and if a person comes in contact with that rat urine, or if a rat urinates into a water system, and if a person comes in contact with that contaminated water, the person would also be contracted with that bacteria. So it is from animals to humans, and especially from rat urine contact with that, the humans would be contracted. So when a break in the skin comes into contact with the urine of certain animals, particularly rats and cattle, but mainly rat. Why cattle also? Because these rat, when they urinate into the food of the cattle, and when the cattle intakes its food, now cattle will also become a main carrier. So occupations at risk from this leptospira bacteria. So any occupations, whoever is working in areas where there are presence of rats, or where there are presence of cattle, for example, the dairy farmers, okay, from cattle, the meat inspectors, okay, the butchers, okay, or pool instructors, swimming pool instructors, the presence of rats or sewer workers. So where there are presence of, or even the vets, okay. So presence of rats or cattle, occupations at risk from this bacterial infection. Okay. So control measures, how do you control through, how do you remove or eradicate these, the rats? So pest control, good personal hygiene, cuts covered with waterproof dressings, trainings provided on risk symptoms. So people, especially occupations at risk, they should understand the importance of maintaining personal hygiene, and the importance of any having a waterproof dressings for any cut, and how these bacteria can cause what are the symptoms, and how to protect ourselves. So training on risk symptoms and precautions, report symptoms of exposure to cattle rat urine to a doctor, wear appropriate ppe, never touch rats with bare hands, thoroughly clean surfaces contaminated with rat urine. Okay. And next is silica. So silica, again, a very fine component of a rock. You will find silica in, in sand, in concrete, in, in granite. So silica is like everywhere. So occupations at risk from silica, constructions, mining, quarries. So those are occupations at risk from exposure to silica dust. So similar to what an asbestos does, silica. So asbestos, scarring of lungs, is called asbestosis. Similarly, silica also scarring of the lung tissues, silicosis. Okay, and lung cancer and chronic obstructive pulmonary disease. Symptoms: shortness of breath, long lasting cough, wheezing, loss of appetite, swollen ankles. So, all these are major health risks from exposure to silica dust. So control, use silica-free materials, use tools with vacuum attachments to capture the silica at source. Okay, so that the silica dust, they do not spread to other parts of the work area. So you're capturing from the point of contact, sprinkling with water, to damp the area so they don't become airborne. Okay, a good personal hygiene, RPE with a suitable assigned protection factor. Now, if you look at any RPE, the manufacturer will provide what is the protection factor for the RPE, to how much of protection it provides. So that also, the protection factor should also be verified when using those RPEs. And use of a vacuum with a filter, high efficiency particulate air filter, so which can trap up to 99.7% of these, microns of less than 10. And then training on the risk to exposure to silica and the precautions to be taken. Okay, so silicosis, very much these fine crystalline silica dust, once they deposit in the lungs, they will scar the tissues of the lungs, and more and more scar tissues would be formed. Okay, uh, so for example, we could see the image. Okay, okay, I'll play a video. I'll stop share and share with the sound. Share sound.
Silica. It's one of the most common substances on Earth. It can be found in materials like sand and rock, and building products like concrete and brick. When a worker cuts, grinds, or drills materials that contain silica, dangerous crystalline silica dust is released into the air. As the worker breathes, silica crystals flow into his mouth and nose and down the air passages deep into the lungs. The tiny crystals enter the small, fragile air sacs, where oxygen is absorbed into the blood. Immune system cells, called macrophages, engulf and try to dissolve the crystals. but they are unable to. Over time, more and more crystals build up inside the macrophage cells. The macrophages carry the silica into the walls of the lung, where they die. Scar tissue forms around the dead cells and spreads as more cells die. This damage can continue even after the exposure to silica stops. Eventually, so much scar tissue forms that the lungs can no longer function. For information on how to protect yourself from silica exposure, visit WorksafeBC.com.
Yes. So you could see what happens when these silica dust when they deposit in the lungs. Okay, so it causes scarring of the lung tissues, and from like it could be from a repeated exposure or a one-off heavy exposure. And when more and more scar tissues are formed, because these scar tissues are not like the normal, the flexible tissues, so they're very hard, and they are big, so that makes breathing difficult, and eventually the lungs will stop. Okay, all right. So the next the last specific agent is wood dust. Okay, so dust from hardwoods are more hazardous than those are softwoods. So generally, hardwoods, they have a very high density, and these are used in the structural beams and flooring. Okay, so inhalation of hardwood dust. So again, the occupations at risk, the woodworking, carpentry, or forestry from the cutting of trees. Okay, irritation in the nose and rhinitis, so inflammation of in the nasal cavity, asthma from inhalation of wood dust because it is an irritant, and more mucus would be produced, so constricting the trachea, and breathing would be difficult. Skin sensitizes, causing dermatitis, and also it is a cancer causing agent, so nasal cancer. So if you are talking about a wood dust as a source of a hazardous substance, please include these in your column number 2. Okay. Control measures use an LEV system attached to the woodworking machinery, as you have seen in the LEV video, where the LEV could also be attached to the component, or as a component to the machine. Use a downdraft table for sanding operations to minimize the airflow. Wear RPE, respiratory protective equipment, and then other PPEs like protection to the hands and skin. The importance of health surveillance, providing suitable welfare facilities, high standard of personal hygiene. So welfare facilities where provision to wash their hands, dry their hands, and providing them with hand washing agents, and prohibit eating, drinking, and smoking when working. Vacuum clean force, never sweep out dust. So always vacuum, do not sweep, because if you sweep, then these dust will become airborne. So vacuuming would be more effective, and provision of information training, so people understand the risk from exposure to these wood dust and the precautions to be taken. Okay, so when you're writing the section 2 of the risk assessment, my hazard category is hazardous substance. Okay, so we should only use here. So hazardous substance is my category, and then tell what is the source of the hazard description. Workers using grinders and disc cutters to dry cut concrete blocks. Okay, so they are cutting the concrete blocks using grinders and cutters. So during this process, silica dust is generated. So silica dust is generated when they are using grinders and disc cutters to cut the concrete blocks or curbstones in an open construction site. Who might be harmed and how? Cutting workers performing the dry cutting task and also any ground workers within nearby distance, because these are airborne, okay, dust. And then exposure to silica dust is irreversible lung scarring, so silicosis, and then lung cancer and COPD. So what we have discussed in the presentation. And then control measures, the importance of creating awareness, use of dust mask, and then how you can eliminate. So buying a pre-cut sizes where possible. So rather cutting at site, buying pre-cut sizes, so that will completely eliminate uh, the formation of this silica dust. And then procure angle grinders and disc cutters fitted with on-tool local exhaust ventilation. 9 o'clock. Okay. And then establish a cutting exclusion zone. So non-essential personnel should not be near that cutting zone area. And then display hazard warnings and PP requirement signage at cutting area. And I will also include a few more. Uh, okay. Okay. So you could see you would keep adding the controls, but do not limit yourself. Include a range of controls. Okay. And then the role of the responsible person, and then include the time scale. So here I have used silica. So instead of silica, if you're talking about any chemicals or biological agents, for example, if you're talking about a bacteria, yes, virus, or asbestos, or carbon monoxide, or maybe where in a workshop they are using a degreasing agent or working with using lubricants. So all this would be considered under the hazardous substance category. Okay, all right. So with this, we will complete for today, and tomorrow I will be discussing the section 3 and section 4. So until section 2 we covered. So tomorrow from section 3, page number 16 of this document. Section 3 requirements and section 4 requirements we will cover for tomorrow. Okay. And then we'll move on to the final week. And in the final week, we'll be covering the remaining 4 chapters. And also we would do the discussion on the second paper. Okay. So tomorrow, I would only be covering section 3 and section 4. So if we have some time, then we would start with element number 8. Okay. All right. So thank you all and have a good one. So reach me if you have any doubts or clarifications. And again, I would be online for another few minutes. So let me know. So thank you, and I'll catch you tomorrow for day 19. Thank you.